All right, guys, here we go. Let's go over this. So I gave you two graphs of two lines, and I asked you to label the points where they cross over the x and the y-axis. So guys, if we look at this line, I'm going to go to where he crosses the y-axis first because you're probably used to using that point. So if I go right here, this is where that line crosses over and touches the y-axis. Does anybody know what ordered pair that is? Y is -2, but what is the x coordinate that puts it right on that y-axis? 0. So that's the point 0, -2. All right, this point is definitely where the line crosses over the x-axis. Does anybody know what ordered pair that is? X is -5 and y is 0. So that's the ordered pair -5, 0. So what we're going to be getting into today are these kind of points. These points where a graph crosses over an axis is called an intercept. If you are an intercept, then you are directly on the x or y axis. This is called the y-intercept because it's directly on the y-axis. This is called the x-intercept because it is directly on the x-axis. And as we start working with more and more graphs, not just the graph of a line, the intercepts become more and more important. So up until now, you guys have been used to using that y-intercept. It's the b in y equals mx plus b. But you're probably not that familiar with the x-intercept. And the x-intercept becomes much more important when we get into harder and harder equations. So if anybody plans on going on to pre-calc next year and the second half of Algebra 2, you're going to notice that, man, we talk about that x-intercept a lot. So we do. It's important points. So when you graph a line, all you need to know are 2 points, and you can connect them and graph a line. So another way to graph a line is to find its x and y-intercept, and then all you have to do is connect them, and you've created the graph of that equation. So it's just another strategy that we can use to graph a straight line, is by using its intercepts. All right, now before we move on, does anybody notice something that these points have in common? 0. They both have a coordinate of 0. So guys, if you have to be directly on the y-axis, then you have to have an x coordinate of 0. If you have to be directly on the x-axis, then you have to have a y coordinate of 0. So if you are an intercept, you are never an entirely unknown point. You know that one of the coordinates has to be 0 if you are an intercept. And that's what we're going to use to help us find them. If we have to find an x-intercept, then we know we have to find x when y is 0. If I have to find a y-intercept, then I have to find y when x is 0. This is exactly how we're going to solve for them, by the fact that they have to have a coordinate of 0, okay? All right, when we get into this today, I also want to just say this now. The reason that we consider the x and y-intercept important points is because we consider the y-intercept the start point. He's like the start point of your graph because he has an x coordinate of 0. So it's kind of like when x is 0 and nothing has happened yet, what's the y coordinate doing? It's at -2. So that kind of acts as like the start point of your graph. And then the x-intercept, he takes on a much bigger role in upper level math because the x-intercept, we think of him, he's the cutoff man. He's the boundary value between where x values make positive y values come out. I know if I plug any of these x's in, they're going to make a positive y coordinate come out. So we know what this end of the graph is doing. And then to the right of that x-intercept, all of these x values, they make a negative y value come out. So the x-intercept, he's the cutoff guy between where positive y values start and where negative y values end. So we use that as a very important point on the graph. He's in between where positive y value and negative y values start and end. And again, that takes on a much more important role in upper level math. But that's why the x-intercept will become so important, okay? All right, so what I want to be able to do with you today is show you how to graph a line using these points. Oh, hold on. So before we go, really quick on this one, who's the y-intercept there? What point is that? The point 1, 0, 1. X has to be 0 and Y has to be 1. And then this x-intercept right there is what point? Negative 3, 0. Again, they have to have that y coordinate and x coordinate of 0 to put them directly on an axis. All right, so again, today I'm going to hopefully show you how to graph a line using just the intercepts. Guys, these are sticking together, so I hope I give you the right amount. If I give you too many, just give it back. Let me know if you need more. Yes. I'm going to get started. Can you at least let me do the intro where you get the definitions? Yes. All right. Let's write our definitions down first before we start practicing. Okay. I always kind of like to recap. We are working with these linear equations still. Linear equations are going to be given to us in two forms. We kind of hope that they're given to us in slope-intercept form. Anybody remember what slope-intercept form of an equation looks like? Y equals mx plus b. Beautiful. And the reason we love to get a linear equation in that form is because we can take very important information right out of his equation. We know that the number in front of x, m, is always going to represent our slope, our rate of change, if you will. And we know the b, the number that goes in for b, always represents your y-intercept, which is one of those important points that we always like to know. So again, if you're a y-intercept, then you are a y value when x is 0. Every y-intercept has to have an x coordinate of 0, so it puts it right on the y-axis. All right, and then if you're not given a linear equation in slope-intercept form, you're probably given it in standard form. Anybody remember what that formula looks like? X plus by equals c. Exactly. ax plus by equals c. Now the downside to being given an equation in standard form is that the numbers that replace a, b, and c, they don't have any meaning. They're not the slope. They're not the y-intercepts. Individually, a, b, and c are just random numbers. They don't have a meaning like the m and the b do. So normally, when you're given a linear equation in standard form, we make you solve it for y, so it can look like that, and then you know your slope and your y-intercept. But if you're not going to do that, if you're not going to solve this for y, then you can graph it by finding its x and y intercept, because it's really easy to find them when they're in standard form. So that's what we're going to try to do. We're going to try to graph lines, not by converting to slope-intercept, but by finding the x and the y intercept and using those points to create the graph. All right, so these important points, let me just define them again and put them in writing, and then we'll practice it. I just want to move mine up so I can fit it all on. Okay. All right. So important points on a graph are the x and y intercept. The x-intercept, by definition, is the point where the graph crosses over the x-axis. All right, so again, just to give you a visual, if you are looking at the graph of a line, that point right there would be called its x-intercept, because that's where the graph crosses over the x-axis. And guys, now remind me, if I am that point, I am clearly in x value. It looks like maybe 3, 4, but what does the y coordinate have to be to put me right on that line? 0. So every single x-intercept will always have an x coordinate but a y coordinate of 0. Because again, it has to have a coordinate of 0 to put it on that line. Go ahead. You don't have to, it's just a visual. Yep. All right. So if you ever have to solve any equation for its x-intercept, then all you have to do is solve for x when y is 0. So go to the equation and let y equal 0 and solve for x. And that's how you're mathematically going to be able to solve an equation for its x-intercept. You know that you're looking for x when y is 0. So let y be 0. Okay? All right, the y-intercept, the one you're probably the most familiar with. He's the point where the graph crosses the y-axis. So again, just to give you that visual, if you're looking at this line, that point right there would be called the y-intercept. It's right on the y-axis. And again, if you're going to go ahead.
So is this stuff going to be on the quiz?
So if this is the y-intercept, he's right on the y-axis. He clearly has a y-coordinate. It looks like -2-ish here. But what does the x-coordinate have to be to put you right on that axis? Zero. So if you're a y-intercept, then your x-coordinate is always 0. And then you have some y-coordinate. We usually call it b because it's y equals mx plus b. All right? So that's how we're going to solve for a y-intercept. We have to solve for y when x is 0. So go to the equation, let x be 0, and solve for y. And that is the strategy that we'll use to find x and y intercepts. Oh, you want me to find the x-intercept? Then I will solve for x when y is 0. Oh, you want me to find the y-intercept? Then I will solve for y when x is 0. Whatever intercept you are trying to find, let the other coordinate be 0, and you'll be able to find it. Go ahead.
You have to like plug in 0.
Exactly. It's super easy.
Just put it in like.
Right in. It is so easy. Now, guys, before we do how easy it is, I want to write one more thing down. Go back to the x-intercept. I cannot stress enough that if anybody is going to go on from Algebra 2, like if you know you're going to have to take pre-calculus, whether it be here in college or wherever, or another calculus, another higher level math class, guys, right now, you're kind of like, yeah, the y-intercept. It's the b from y equals mx plus b. You know him. He's kind of always been the more important intercept, if you will. But in upper level math, guys, it's going to take a turn, and you'll see it in chapter 4 of this year. It becomes all about who's the x-intercept? Who's the x-intercept? Maybe there's more than one. Who are they? Where does the graph cross over the x-axis? In upper level math, it's all about x-intercepts. I don't know if I have gone through a section or a chapter with my pre-calc students where we have not found an x-intercept. It is extremely important, him being that cutoff guy between positive and negative y values. So you'll deal with him a lot in your next math class. He has another name. I want you to know that name. So the x-intercept is also called the 0. If you are ever asked to find the 0 or the zeros, plural, you have literally just been asked to find x-intercepts, to find points where the graph crosses the x-axis. And if you're wondering why he got the name the 0, it goes along with kind of like functions. Does anybody remember when you're working with a function, who did we plug into the function, x or y? X always went in. Something happened to it, right? Some mathematical rule. And then the function always spit out who? Y. And then that's how we created all those ordered pairs x, y. Okay. Well, if you think about how an x-intercept is, it means an x value has to go in, something has to happen to it, but who has to come out as the y coordinate? Who has to be an x coordinate, an x-intercept's y coordinate? 0. So you literally have to have an x value that makes a 0 come out. And that's how we got the name the 0. The x-intercept got the name as the 0 because the x-intercept is the number that you have to plug into the function that makes a 0 come out. So this is the number that makes the equation equal 0. This is the number that makes the function equal 0. So he's the 0. He's the number that makes 0 come out. So just know that for the future, because when you get to pre-calc, I don't even know if they say x-intercept anymore. They just say find the 0. And you have to understand that the 0 is the x-intercept. It is the x value that makes the equation equal 0, that makes y be 0. So please get used to that, and you'll definitely hear me talk about that in chapter 4. You'll hear the 0, but it's an x-intercept. It means the same thing. All right, let's do it. Watch how easy this is going to be. So let's practice. Just want to get myself more room. It's a little cramped. All right, so what we're going to do, in example A, B, and C, we're going to find our x and y intercept. And then in problem 2, we're going to use the intercepts we found to graph that line, all right? All right, so guys, here's the first example. They want you to find the x and the y-intercept of this linear equation. It's in standard form, which is great. All of your homework problems are going to be in standard form. I gave you these two because our book used to mix it up a little bit, but really we don't use the book. I use Delta Math and everything like that, and they'll all look like this, so you'll be fine. Okay, so guys, I do it like this purely for organization purposes. Do it, don't do it, it does not matter. It has nothing to do with getting the answer. They asked us to find the x-intercept and the y-intercept. So this is how I organize my information. I'm going to find the x-intercept first. Guys, if I'm finding an x-intercept, that means I am solving for an x value when the y-coordinate has to be who? 0. So I always use that as a map. That means I'm going to go to the equation. I'm going to solve it for x when the y is 0. So let y equal 0 in the equation. So here we go. 2x stays. Minus 4, not times y. Y has to be 0 for an x-intercept. And then it equals 12. And then here's the beautiful thing, guys. We're dealing with 0. What is negative 4 times 0? It's 0. It's gone. What's left? 2x equals 12. That's all you have to solve. And you're going to find the x-intercept in like 3 seconds. 2x equals 12 is left. Divide both sides by 2. And who is the x-intercept going to be? 6. That means that on this graph, the line would cross over the x-axis when x is positive 6. All right, now delta math, on your homework, guys, it's going to have x equals with an answer box, and all you have to do is type in 6. However, you really do have to get used to seeing intercepts written as ordered pairs. So if you had to write your answer as an ordered pair, x is clearly 6 when the y-coordinate was who? Yeah. So that's what it would look like written as an ordered pair. All right, let's do the y-intercept now. Go ahead, Darren.
How did you tell? On a test, how would you tell? Like, we would write both coordinates.
Which one?
Like, how would you give me the answer?
I would either say, give me the x value, or I would say, give me it as an ordered pair. All you have to know, though, Darian, is if you just solved it for x, then that's your x coordinate, and the other coordinate had to be 0.
Yeah, that's what I'm saying. How do you tell if it's a y or the x?
Because I asked you to find the x and the y-intercept, and I just said I'm going to get the x-intercept. So the x-intercept, Darian, you're solving for x, because it's the x-intercept. So if you're solving for the x-intercept, then let the other coordinate be 0. Am I answering your question? No? You had to find both. I chose to find the x-intercept first. So I chose to solve for x when y was 0, because that's what an x-intercept is. Is that okay? All right, go ahead, Paul.
So like if you find the y-intercept too, so it'd be like 6 and whatever, can you write that as an ordered pair?
No, they have nothing to do with each
So
other.
it'd be 2 separate.
2 separate. That's a great question. You can never take the x-intercept and the y-intercept and write them together as an ordered pair. They are 2 entirely different points. You cannot write them as an ordered pair together.
So on the homework, you just put 2 separate answers.
Mm-hmm. Yeah, on the homework, Paul, it's going to have an answer box for x, and then underneath it, it'll have an answer box for y. Okay? All right, let's do the y-intercept. So the y-intercept, I am definitely looking for y, because it's the y-intercept. But what does x have to be in a y-intercept? 0. So in that case, you're looking for this. So I need x to be 0, so I can go solve it for y. So go to the equation and let x be 0. Like I said, whatever intercept you are solving for, then the other coordinate needs to be 0. All right, so we're going to do 2 times 0, and then minus 4y equals 12. Guys, what's 2 times 0? It's gone. It's out of the problem. What's left? Negative 4y equals 12. And now what's the only thing you have to do to get y by itself? Divide by negative 4. And now you know the y-intercept is when y is negative 3. So that would be your answer on Delta Math. All you'd have to do is type in negative 3. But in the future, if you had to write it as an ordered pair, clearly the y-coordinate is negative 3 when the x-coordinate was who? 0. So it would look like 0, -3. Okay, so that means that this graph would have a y-intercept at -3, and you could connect the two dots to graph it. Okay? Now, what was I just going to say? I was going to say something. You made me think of something, and I don't remember what I was saying.
Like combining them? So
Yeah,
like
maybe.
6 negative.
Yeah, Paul was saying, could I write 6, -3? No, you can't do that. You have to write them, they have to stay
So
separate.
you would never do that?
Mm-mm. Unless you were like listing them as 6, -3, not as an ordered pair, but it's never going to ask. I'm never going to ask you to do that. Okay? All right. Oh, that's what I wanted to say. So if you wanted like a quick visual, this is how my algebra teacher always told us to find the intercepts. Our school is very big on making you plug in the 0 and seeing it. My teacher called it the cover and solve method. If I want to find the x-intercept, then go to the equation, leave the x part, and cover up the y part. Because I'm going to have to let y be 0 anyway, so what's 0 times -4? 0, it's gone. And then all that was left was the 2x = 12. And it was a really easy visual to see what was left. If you want to find the y-intercept, then cover up the x part. And then what's left? -4y = 12. And it's exactly what we got. But she always nicknamed it the cover and solve method. If you want to find x, cover up y. If you want to find y, cover up x. And then just start solving whatever is left in the problem. So if that helps anybody for a quick, like really quick visual, then please. All right, so all of your homework is going to be given to you like this, in standard form. ax plus by = c. Find the intercepts. Like I said, our book, we used to have to use our book a lot. Now we use Delta Math and all that stuff. They always would try to throw like little curveballs at you. So let's find the x and the y-intercept when it's written not in standard form. It's the same process though. And I just do this to organize myself. If I want to find the x-intercept, that means I am solving for x when y is who? Who does y have to be in an x-intercept? 0. So I use that as my map. I'm going to solve for x, and I'm going to let y be 0. So let y = 0, or cover that part of the problem up. And then 3x plus 6 = 0 is left, and that's what you have to solve. All right, but if I plug in 0, it's going to be 3x minus 0 plus 6 = 0. Guys, what's 3x minus 0? It's 3x. The minus 0 is gone. He doesn't have an effect on anybody. And you are left with 3x plus 6 = 0. And there is no equation that we can't solve. What are you doing first to get x by itself? Subtract 6. Nice and easy. 3x equals -6. Divide both sides by 3. And who is the x-intercept? -2. So on Delta Math, all you have to do is type in -2. Call it a day. If you had to write it as an ordered pair, though, in the future, x is clearly -2 when y was who? That's the point -2, 0. Go ahead, Paul.
On the quiz, you want to
I
say?
might make you make an ordered pair. That's why I want you to just be ready for either one. All right? Look at the y-intercept. Let's get the y-intercept now. If I want to find the y-intercept, then I am definitely solving the equation for y. I need a y value, but x has to be who? 0. So that's the ordered pair we're looking for, 0, y. So go to the equation and let x = 0. Or, guys, cover the x part up and look at who's left. -y plus 6 = 0. Solve that. If I do plug in 0, though, it's going to look like 3 times 0 minus y plus 6 = 0. Guys, what's 3 times 0? 0. It's gone. The only thing left is -y plus 6. Go ahead, Dara.
Would you subtract right there, like to the
Here?
-6? Yeah.
Here?
Yeah.
You have two options. Guys, if I've trained you right, then you're probably thinking -6 divided by -1, and I love you for it. But if you really want to, dazzle yourself, all you really have to do is add y to that side, and then what's y going to be? If I add y over here, 6 is left. What's 0 plus 3? 3. So what's 0 plus y? Y is 6. So again, if you like, dude, lady, I don't know what the hell you just did, then -6 divided by -1. But that's another way to get y by itself. Sometimes it's easier just to move the y and not the number. That means the y-intercept is 6. That would be your answer on Delta Math, the 6. If you had to write it as an ordered pair, y is 6 when x was who? 0. That's the 0.06. Because tomorrow you have to know ordered pairs. Go ahead, Bianca. Good? Oh, yeah. All right, last one. Now this one's kind of like a hit and a miss, if you will. Let's say you had to find the x and the y-intercept. Okay, I'll play the game. Guys, tell me right now, what form of a linear equation is that in? So who's your y-intercept? Negative 8. You already know the y-intercept is b when you're in y equals mx plus b form. So don't miss these gifts. This one, we know who the y-intercept is just by looking at the equation. So I know right now that the y-intercept is when y is equal to, and again, maybe I'll say b is equal to the y-intercept, which is equal to negative 8 in this problem. So you already know the y-intercept, and you didn't have to do a darn thing to do it. But guys, if you remember, you would normally find the y-intercept by letting x be 0. If I let x be 0, what's negative 2/3 times 0? 0. What's 0 minus 8? Y is negative 8. The y-intercept is definitely negative 8. All right, so on Delta Math, all you'd have to do is type negative 8. But if you had to write it as an ordered pair, y is clearly negative 8 and x is 0. All right, now let's get the x-intercept. All right, we got to get the x-intercept. We are looking for x when y is who? 0. So go to the equation and let y equal 0. Or, like I said, if you cover that part up, it's kind of like, ooh, wait, what just happened? You got to let y equal 0. So 0 equals negative 2/3 times x minus 8. So guys, we got to solve this for x. And there is no equation we can't solve. What are you doing first to get x by itself? Plus 8. Get the one that's not attached away. And now you're left with 8 has to equal negative 2/3 times x. Now guys, humor me. You have options. If this was just equaled negative 2x, what would you have done to get x alone? Divide both sides by negative 2. So if you want, since this is negative 2/3 times x, go ahead, divide it away. Divide both sides by negative 2/3. If you are confident that you can type that into your calculator correctly, you go right ahead. I would just advise that if you do this, I would do 8 division symbol, and I would put negative 2/3 in parentheses to keep it together as one fraction. I'm just a very big fan of parentheses around fractions. All right, if you didn't do that, and you're afraid like, Hardy, I'll probably mess that up, then I have also told you in the past, if you want to get rid of an entire fraction, then times it by its reciprocal. Any fraction multiplied by its reciprocal just becomes positive 1, and then you'd be left with a positive 1x, which is x. Think of it as the 3 up here and the 3 down there cancel, the negative 2 down here and the negative 2 up there cancel, and you're left with just x. But then that means you have to times this side by 3 over negative 2. But we can do it. We can do it. Multiplying fractions is the easiest thing. Put 8 over 1, and now what's 3 times 8 on top? 24 over what's negative 2 times 1 on bottom? What's 24 divided by negative 2? Negative 12. All right, and now you know your x-intercept is negative 12. So that means x is negative 12 when y is 0. It would look like that as an ordered pair. All right, what we're going to do is I'm going to write these down. Now we're going to take this x and y-intercept and create his graph if you didn't already do it. Take his x and y-intercept and create his graph. Yeah. Oh, wait till she comes back. Let's just do this graph real quick. Yes, Darren. 24 over negative 2. 3 times 8 is 24. Negative 2 times 1 is negative 2. I know, it's very cramped. I apologize. All right, we had a 6, 0 with a 0, negative 3 on the first one. We had a negative 2, 0 and a 0, 6 on the next one. Negative 12, 0 and a 0, negative 8 on the third one. Guys, I apologize. The third one does not fit on the graph, but we'll make it work. So all we're doing is substituting zeros for either coordinate and solving for who's left. All right, so the first one, if we graphed example 1, it had an x-intercept at 0, 6, so it crosses the x-axis when x is 6. It had a y-intercept at 0, negative 3. There's your 2 dots, connect them, and you've graphed the line. and you didn't need its slope. Now, guys, can I just say this and take it for what it is? If you ask me, hey, Hardy, who's your favorite? How do you like to graph? Do you like to use slope intercept, y equals mx plus b, or do you like to find the two intercepts and connect them? I will always pick slope intercept, because when you have a slope, you can create as many points as you want. I can go up 2, right 3, up 2, right 3 all day long, or down 2, left 3, down 2, left 3, and I can create 1,000 points. When you graph a line using its intercepts, then technically they're the only two official points that you know on his graph. So I like the slope because it gets us so many more points. All right, this one had an x-intercept at -2, right there, crosses the x-axis. It had a y-intercept, I think at 6, was it 6? I think so. Was 6, all the way up there. Connect the two dots and you've graphed the line. All right, and then last, wasn't big enough. If you want to count by twos, go ahead. I hate doing that. 8, 9, 10, 11, 12, -8. It had an x-intercept all the way over here at -12, and it had a y-intercept all the way down here at -8. Connect the two dots and call it a day. So again, it does get you a quick graph. The intercepts, you can get them pretty quickly, bless you, and all you have to do is plot them and connect them, and you have graphed that equation without ever knowing his slope. Like I said, not a huge fan, but it is a good strategy to know. All right, I want you guys, if you haven't done it already, I want you to find the x and the y-intercept and then graph it. And I'll tell you right now, you get a decimal. And I wanted you to get a decimal because I know you're going to get a decimal on Delta Math night, and I don't want you freaking out.
Right.
Go ahead. Perfect, absolutely perfect.
I was gonna say.
You are definitely going to get a fraction or a decimal. Beautiful. Except 15 divided by -5 is -3. Okay. And then all I want to do, guys, is I want to show you what your homework is going to look like, because you might have questions. And I want to make sure that I address them before you leave.
I don't know what this is. I don't have a calculator.
7.5.
Oh, yeah. So. You're right.
Let me see, Paul. Yeah, except 7.5 is over there. That's negative. So then that's right, and then we should just put that right there. Guys, just be careful you don't lose a sign. Because some of you are going to find them in like literally 2 seconds just by looking at it, which is great. That's why I think the cover and solve is amazing. Like, I'll never forget my teacher doing that, because it makes you get the answer so quick. But don't make any silly mistakes by doing that. Check your answer with mine when you're done. All right. Can I just warn you guys? I saw a handful of your answers and they were beautiful. The x-intercept ended up being a fraction or a decimal, because when you put in your 0, you end up taking 15 and divided it by 2. Delta Math will not let you put a decimal as your answer. You have to put the reduced fraction, and it'll say it in the directions, so please watch out. So you would have to put in your answer as 15/2. However, when I go to graph, I always convert it to the decimal to make graphing it easier, okay? So graph the decimal, but you have to write the fraction as your answer. Question.
137
Yeah, I always get the decimal for graphing purposes, because it's easier to graph a decimal than a fraction. All right, yes.
I'm not put it test.
Yeah.
If we put a decimal.
I don't, but if it's like a Delta math quiz, then it's gonna count. Yes, Brendan.
That intercept 4.
You can do it. Your y-intercept will be B. You still gotta get x though.
You have to get it.
If they ask for the x-intercept, you have to get it.
So you can't count up the X in the
If it gets you to, maybe it is a fraction and you can't count exactly to where it is. All right, guys, now do this. I have 5 minutes, so everybody please, I have plenty of time. You can pack up in 30 seconds or less. I just want to show you Delta Math because I'm a little upset about it. And I just want to make sure everybody's on the same page. When you do your homework tonight, everybody just at least look like it's ready to pretend one? Okay. Let's see, I'm not bad. There are 3 types of questions. I think you have to get 4 correct, and then 3 correct out of the 3 different types of questions. First kind is the best. The first type of question, and I believe you have to get 4 of these correct, is guys, they're going to tell you to find the x and the y-intercept. Here's your equation. Type the x-intercept here, the y-intercept, not an ordered pair, literally just the number. And they tell you, if it's a fraction, put it in simplest form. So if x was 2, 2. If y was 3 halves, call it a day. That's the best one. It's the most straightforward. You will not mess that up. The next section, I think you have to get 3 of these correct. They're going to be, it's matching. It comes in 2 different forms. They're either going to give you an equation. You have to find the x and the y-intercept and then match it to the correct graph. That's not bad. You get your x-intercept, cover the y, 40 divided by 4x is 10. So look for an x-intercept at 10. All right, cover up the x, divide 40 by negative 10, the y is negative 4. Look for a y-intercept at negative 4, that's great. But they might give you one graph with 4 different equations. And then you have to match the one graph to the correct equation. And again, I would just look at the graph, see who your your x-intercept is, see who your y-intercept is, and then which equation could get you them. You have to get 3 of them correct. And then this is the last one. This is what I'm sorry for. The last one, they give you an equation. You have to find the x and the y-intercept. Then you have to slide the red dot to where the x-intercept is, and you have to slide the blue dot to where the y-intercept is. But here's the problem. You're going to get decimals. You're going to get fractions. It looked like it was being really, really nice. Guys, the x-intercept. What's 21 divided by 3? So the x-intercept is 7. So you would slide this to 7. All right, the y-intercept. What's 21 divided by negative 7? So the y-intercept is negative 3. So you would slide this to negative 3, call it a day. However, some of the problems, guys, you're going to get decimals. So let's say you got 21 divided by 8. Anybody have a calculator? What's 21 divided by 8? Just pretend it was 20, which was an 8. Is it 2 point?
I don't know, it's not.
It's not working. Hit the on button a bunch of times. 21 divided by 8.
Error.
2.6.
2.6. So here's the thing. I thought, let's just say it was the x. I thought as long as you slid the red dot anywhere between 2 and 3, it gave you credit. It's being really temperamental. If it's 2.6, then please make sure that it is closer to the 3 than it is the 2. And for the love of God, don't put it in the middle because that's 2.5. I'm telling you right now, it's so much pissier than I thought. So you might do 4 problems, and guys, I'm telling you, it's going to tell you that this was the correct answer, and then here was your answer. It is being so freaking nitpicky. It didn't look like it was being nitpicky when I assigned it. We did 3 problems in a row last class, and marking around every single time. So if you get 4 problems and you're like, Hardy, I'm going to throw my Chromebook, because you guys have a trackpad, not even a mess. I understand if you skip that. Please give it a try. But if it gets to a point where like, Hardy, this is the most annoying thing in the world, I get it, just come in and tell me tomorrow. It didn't look like it was going to be that annoying when I assigned it. But I'm telling you right now, I got marked wrong 3 times in a row because I wasn't close enough to where they wanted that freaking decimal.
Maybe put it too close.
So I am just very sorry about that section. All right, so just try it, but if it's annoying, I get it. All right? Have a great day. I'll see you tomorrow. Yep.
Okay, so. Ooh, Abby. Okay.
Have a good day.
You too.